Hey everyone, this is Greg. How are you today? This is a first. We're going to do a combined video for 608 and 518, which just so happens we're on the same topic. I'm going to use the Week 6 DQ1 example from MGT 518 though to walk through this. So we're going to do a hypothesis test for a proportion today. And I'm going to show you how to use a calculator I found that should make it quite a bit easier. So let's go through the setup, and I'll use the numbers and then show you how the calculator works. Alright, so the null hypothesis here was that some population proportion was 60%. Alright, and I think that was the cholesterol, no, the number of people that, something, it was 60%, doesn't matter. Well, I take my sample, and if I use the calculator, which I've sent you, the calculator allows me to put in the sample size, 200. Let's go over here. There's the sample size, 200. And out of my sample, I had 128 out of 200 people with that characteristic. So I put that percent here. That's 64%. That's how the calculator works. So there's 64%. There's 200. Now the null hypothesis is 60%. So that goes here, and then I simply click the test button, and it gives me my z-stat of 1.155. So let's go over that again. I had a sample of 200, and out of 128 positive responses, that's 64%. So that number goes here. The null hypothesis was that it's 60%. So all hypothesis testing works the same way. And once you get a hold of this, it has several applications. Alright, so the first thing I'm going to do is I got my picture drawn, and I got my critical value on each side, because this is a two-tailed test, because we have an equal sign up here. So I'm going to compute the test statistic. Now, I'm computing a z-stat test statistic, not a t, because I'm doing a proportions test, and that's important. Well, I don't even have to use the formula now, because we found that really good calculator, which gave us a z-stat of 155. So now the work's done. Now the thinking part starts. Second step, I got to find the correct critical value for a two-tailed test. Now, it's not a one-tail, it's a two, and I'm going to use the z distribution. Well, on that last table I gave you, there is a z at the bottom and a t at the top. So I go to the bottom, and if I have an alpha of 0.05, then at the bottom of the table, the two-tailed z critical value is 1.96. So I'm going to write these right here. That's negative 1.96, and that's positive. Okay? Now, it's important to remember when you're getting a z critical value, degrees of freedom do not matter. That's only if you're getting a t critical value if you're doing a test for a population mean. Alright, but you should have the picture drawn. Now, the test stat only goes over to 1.155. It doesn't go over as far as the critical value. So, our result is we fail to reject the null hypothesis at an alpha of 0.05. So that means somebody says that the percentage of people in the population that like blue is 60%. And from our sample, which is 64%, we cannot say that's not true, because that sample proportion is not extreme enough. And that's all you have to do on a hypothesis test for a proportion. Now, when it becomes one tail, then your critical value is going to change. And then you may come to a different conclusion. But essentially that's it. So spare yourself the algebra lesson and use that z-stat calculator for all proportion problems. It will work. Okay, thanks, and to EDD 608 and MGT 518. Everyone have a wonderful day. Thanks. Bye.